We have discussed the number codes such as Gray code and BCD that are slightly different from the normal binary number representation of numbers. But then we need to address how alphanumeric characters are represented in digital systems. And we notice that a computer needs to be able to process both numerical and character form. This includes such numbers as 0 to 9 and alphabetical characters A to Z, and this may involve the small and capital letters. And we also include special symbols like this pound, asterisk, double quotes, question mark, among many others. So since the computer stores such data in binary format, mostly in zeros and ones, we need to have a coding scheme that we can use to represent any given symbol, be it an A. How do we store an A in a computer? How do we store a Z in a computer? How do we store a number 9? There is number 9, we may have met it, but what you should know is that a computer system does not use 9 as 9. We have a character code that we may use to represent it, and you'll see it shortly. So two schemes are known that are quite popular in representation of characters. That is the ASCII and EBCDIC. We start with the ASCII. ASCII is pronounced as such. That is ASCII, and it stands for American Standard Code for Information Interchange, which is the one mostly used worldwide. It has a 7-bit code, which is adequate for representing 128 characters and numbers. But we also include an additional 1 bit. Sometimes it is reserved. So ordinarily it works as an 8-bit code, but at least you only have 128 numbers and characters that are represented using ASCII. The numbers are represented as starting with 0 and 1, and then followed by the 8421 BCD format that we have met earlier. So for instance, if we wanted to represent 8, we would say 8 is going to be represented by 011 1000. We know this is the number, the bits that represents the BCD for 8, and the number, this first number is used by the ASCII formatting form to represent, or for the computer to recognize that the digit that we are receiving or the symbol that we are receiving is a number. The 26 uppercase and lowercase characters plus other special characters are represented in the table that follows. So you can see that we can have all types of characters and special characters and alphabets. So what we observe about the character codes that are used with ASCII is that letter A, capital or small, use different code when they are represented in a computer system. And we are observing here that the most significant bit for capital A is 100, and the least significant bit for number A is 0001. So if you wanted to, whenever you place keyboard for character A, what you are simply setting to the computer system is the most significant bit 100 plus 0001. So that is what the computer receives. When it receives that, it recognizes that that is character A. When you press small a, you are simply setting 1100001. So this is how we need to recognize how this table is supposed to be interpreted. This is the least significant bit indicated as such, and the most significant bit, I believe they start here. Some of these are special characters that you can find. Whenever you place the hash key on the keyboard, what you are setting on the computer is this 010 followed by this code, which is 0011. And therefore that becomes rather straightforward. So most of the times what is changing is the most significant bit, and all these others are represented. So whenever you see these characters that you do not recognize, their meanings come here next, and sometimes some of them you may understand them, some of them you may never have seen them, but just notice that they represent different forms. Some of them are printable, others are not printable. For instance, you can have an escape. This we normally see it in our keyboards. The backspace is normally seen. The tab is normally seen. Some of them you never see them. This is the carriage return or enter. Others you never see them, but sometimes can be printed. So that is how we use the ASCII to represent different characters. Here's an example that says that Z, if you want to represent Z using the ASCII, you will have the most significant bit being 101 and the least significant bit, the one we are calling LSB, represented by that, whereas lower z or lowercase z is having the same LSB but a different MSBs. It can be noted that the upper and lower case of particular letter in the alphabet has the same LSBs, whereas they have different MSBs. We have already seen that. The ASCII format has several non-printable characters, and we have also seen those ones. And we say that although it is a 7-bit code that allows us to represent 128 characters, there is an additional extra bit that is normally inserted as MSB, so that it is sometimes used to as a reserve, and we may use it in future whenever we need an additional representation of characters that are not represented in the 128 characters. This transforms the ASCII code to become 1 byte long, which is quite comfortable in most computers. Most computers work with 8-bit scheme. The extra bit serves as a data check sometimes, which can be discussed at a later date or at a later time. In some variations, the extra bit may be used as for accommodating special characters that are not within the 128 symbol scheme. We now talk about EBCDIC, pronounced as such, and it stands for Extended Binary Coded Decimal Interchange Code, which was developed by IBM, and it has some similarities to ASCII. A major feature of EBCDIC is that it uses an 8-bit code, and therefore it can accommodate 256 symbols.